All of these four fundamental things are seen within the Martian meteorites. So, the conditions could be right for life to exist on Mars, perhaps in the past.
And it seemed the NASA team was about to prove it. Thanks to that odd little meteorite, 84001, from Mars.
600 million years after this rock was formed in the crust of Mars, you get water percolating through the rocks, saturated in carbon dioxide from the Martian atmosphere. As the water basically evaporates away, it potentially leaves the carbonate behind.
So the meteorite confirmed that Mars had once been wet. But there's more.
The carbonates contain organic matter. The carbonates contain an iron oxide mineral, magnetite.
Here on Earth, magnetite, essentially magnetic crystals, are often produced by microscopic life forms. This was getting exciting. Using the most powerful microscope at their disposal, the investigators now looked even closer and got the surprise of their careers. They saw what looked like minute, worm-shaped structures. Quietly elated, the scientists were cautious.
We said one explanation could have been biology operating. Could have been the signatures of something like a life process.
So was this finally confirmation of life on Mars? Well, from the moment they were announced, the microbes have been controversial. Critics say that the carbonates, organic matter, and magnetite crystals can be explained through other non-life processes, and many believe that the worm-like structures are actually clumps of a coating material used to examine the sample in the laboratory. Still, others point out that the rock could have been contaminated at any time, perhaps when it was lying around for thousands of years here on Earth. Nevertheless, the possibility of ancient Martian bacteria raised the ante on life on Mars. If once upon a time Mars was warmer and wetter and had some early form of microbial life, did it survive, thrive, and grow up to build like an Egyptian? Well, it's a nice idea, but seems unlikely when you consider that conditions on Mars are dry, radioactive, and extremely cold. How could anything survive in this hostile environment? But we could be underestimating the nature of life itself. Microbial life, that is. Believe it or not, astrobiologist Penny Boston is searching for life on Mars by dropping deep into this heart of darkness. This is a lava tube, a subterranean cave formed by underground lava flows during volcanic eruptions that occurred thousands of years ago. And Boston has someone she wants us to meet.
Sometimes they're in crevices, sometimes they're kind of hard to see.
Is this when the scary monster reveals itself?
Ah, there's one.
Actually, no. This is an extremophile.
We're looking for what we astrobiologists call extremophiles in this environment. And that means that they're organisms that are living in very difficult conditions. In this particular case, these organisms are living in a very cold cave right around freezing. They are making their living without benefit of sunlight, and there's almost nothing to eat in this cave.
In recent years, scientists have discovered tenacious microorganisms living in all forms of extreme environments. So if on Earth, why not on Mars?
We think that Mars is covered with lava tubes. We believe that by looking at organisms that live in these extreme circumstances on Earth, we can learn a lot about what to look for on Mars, and that similar Martian organisms may be able to persist on Mars in places very similar to this lava tube.
To find out, Dr. Boston has created her own little Mars environment biospheres, essentially exposing a range of microscopic Earth life forms to various elements to be expected on Mars.
They have been subjected to Mars-like levels of high ultraviolet radiation and Mars-like temperature cycles. We have given them atmospheric compositions from very low levels of carbon dioxide with nothing else to perhaps 1/10 the density of Earth's atmosphere, and tested them under those conditions.
And so far, she's isolated 36 different strains of organism that thrive quite happily. So in theory at least, life could survive the harsh conditions of Mars, except for one problem.
There's one thing for sure that we know, and that is that all forms of life on our planet require liquid water. We don't know if that's going to be true on other planets, but we think that where there's going to be life, there's going to have to be water.
This simple fact has helped scientists in the 21st century refine the search for life on Mars into a comprehensive strategy. Dr. Jim Garvin is chief scientist at Goddard Space Center and a veteran of NASA's Mars exploration program.
NASA uses a term, follow the water, following the history and record and abundance and inventory